Alright, today we're going to be learning about inverse functions, and we learned how to find inverses graphically back in Unit 1, so now we're going to learn how to find them algebraically. An inverse function, in general, is a function that undoes another function. So when we're finding inverses algebraically, if it's not already written as y equals, so a lot of times it's going to be written as f of x or g of x or a letter of x. We're going to change that to y. Then if you remember when we were finding inverses graphically, that when we went to find the inverse, the x's and the y's all switched. Well, we're going to use a similar idea here, and we're going to switch x and y. Then we're going to rewrite that equation by solving for y. And then in our final answer, we're going to rewrite y as either f to the negative 1 exponent of x, or g to the negative 1 exponent or x, or whatever letter we have to the negative 1 exponent of x. And what this notation means is this basically is saying the inverse is blank by putting that before the equal sign. So the negative 1 exponent basically just means the inverse here. So let's look at some examples. So in the first one we have f of x equals f of x equals x plus 4. We're going to rewrite this as y equals x plus 4. So that's step 1. Step 2, we're going to switch x and y. So we're going to switch it to x equals y plus 4. And then we need to get y by itself. So to get y by itself, we're going to subtract 4 on both sides, and we'd have x minus 4 equals y. And then for our final answer, we need to rewrite y. Instead of y, we're going to put our inverse notation. So f inverse of x equals x minus 4. And that's all you have to do. So let's try another one. Switch a of x to y. Switch our y and our x. And just the letters move. None of the numbers around them move. Then we need to solve for y, so we're going to add 1. And divide by 2. Now, in this situation, we could leave the fraction like this in one big fraction, or it might also be written as 1/2 x plus 1/2. For me, either answer is acceptable, but if you're doing multiple choice, you need to recognize that this and this are the same thing. And then we need to rewrite it in inverse notation. So a inverse of x equals 1/2 x plus 1/2. And when it comes time for the SOL probably split it up like I did here. So let's move on to some trickier examples. Rewrite g of x as y. Switch our x and our y. And then solve for y. So subtract the 2, subtract the 2. The way we're going to undo the 1/3 in front of the y is multiply both sides by 3. So these 3's will cancel out on the right, and we just get y on the right. On the left, make sure you distribute the 3 to both terms that are on that side. So you should get 3x minus 6, and then rewrite your final answer in inverse notation. Example number 4, we're going to change h of x to y, switch our x and our y, and again, make sure you're switching just the letters, the exponent stays where it was. We're going to solve for y, so subtract 3. To get rid of our squared, we're going to square root both sides. And thinking back to our quadratics unit, whenever you square root both sides, make sure you put plus or minus in front of your answer. And then finally, write our answer with our inverse notation. So that's how to find an inverse. Now we're going to look at how to prove a function, prove two functions are inverses of each other. So if f of g of x equals x, let's go this way. I'm going to make it nice and bold. And g of f of x equals x, then f of x and g of x are inverses. So we're going to use the compositions that we learned last class. So the first thing we need to find is f of g of x, and then we're going to simplify that. So we're going to take our g, plug it in to f, so we'll have 2 times 1/2 x plus 3 minus 6. So we need to simplify this. We're going to distribute the 2. 2 times 1/2 is just 1x. 2 times 3 is positive 6. Bring down the minus 6. Combine like terms, 6 minus 6 is 0, and we get just x. So far, that's good. We're halfway to showing that they're inverses of each other. The other thing we have to do is g of f of x so take f and plug it into g. So 1/2 times 2x minus 6 plus 3. Simplify, so distribute. Half of 2 would just be 1x. Half of minus 6 would be minus 3. Bring down the plus 3. Negative 3 plus 3 would be 0, so we're left with just x. So since we got just x for both of them, yes, they are inverses. And the number one thing to be careful of, it's not if they equal the same thing. We couldn't get x plus 3 for both of these and say they're inverses. It has to be just x, because everything one function does, the other function has to undo. So let's look at another example. So we're going to start out with f of g of x. And if you really wanted, you could start with g of f. It doesn't matter the order that you do them in. So we're going to have 4 minus x plus 4. We got to distribute the negative, so we'll have 4 minus x minus 4. Combine our like terms, and we're left with negative x. This is not just x, so we know that they are not inverses. Now, if you were to do this on a quiz or a test, I would recommend double checking g of f of x. So let's try it. 4 minus x plus 4. And if we combine like terms there, we get negative x plus 8, which is also not x. So we confirmed that they're not inverses. So let's look at one more example. F. And it's very important with these to make sure you do the correct order of operations. That's the number one mistake that I see students make in these problems. So the cube root of x plus 3 cubed minus 3. So because plus 3 is inside these parentheses, we can't combine it with the negative 3 yet. But we know that a cube root undoes a cube. So we'll have x plus 3 minus 3, combine our like terms, and we're left with just x. If we plug f into g, we'd have the cube root of x minus 3 plus 3 cubed. Now here, we can't undo the cube and the cube root first because we have other stuff inside this parenthesis. So we need to simplify what's inside the parentheses first. Negative 3 plus 3 would be 0, so we're going to be left with the cube root of x cubed. Cube and cube root undo each other, so we're left with just x. So yes, they are inverses. That's all for today.